Hello and warm welcome to everyone joining us today. I'm your host Dalvinder Kaur from lovely Professional University. Let's dive into today's topic, containers in Google Cloud Platform. Before we proceed further, allow me to introduce the experts of the day. Ms. Kunsirat Kaur, Assistant Professor, Mittal School of Business, lovely Professional University, specializing in cloud computing and game designing. With a strong academic and practical background, she has actively guided students in various innovative projects and more. Her dynamic teaching approach and subjects expertise contribute significantly to fostering a culture of innovation at the university. So now I would like to introduce Mr. Sai Subramaniam also in this webinar. Welcome, Mr. Sai Subramaniam. He is cloud computing and data science specialist. He is dedicated to imparting industry relevant knowledge. Mr. Sai consistently fosters a learning environment that promotes innovation, problem solving, and technical excellence. Before we proceed further in today's session, I would like to request everyone for any questions you can write in the chat box or in the Q&A box, and same will be done from my side in the end of this webinar. Now I'm going to hand over this session to our experts, Ms. Kunsirat Kaur and Mr. Sai Subramaniam, and it would be an absolute delight to listen from them. Over to you both. Yes, over to you, Mr. Sai Subramaniam.
Yeah, thanks. Very good afternoon. I hope, I'm audible to everyone and
Yes,
everyone can see my screen.
yes.
Yeah, I need a confirmation as if you can see my
Yes,
screen and you can hear my voice.
Yes,
yes, you're
everything is
audible
fine. You can
and
continue, Mr. Sai Subramaniam.
Yeah, thanks. Today's webinar, we are going to talk about containers in Google Cloud Platform. So I have an agenda to understand this webinar where we are going to talk about how and what is containers. Nowadays, if you see industry follows, they develop and they deploy the applications in the form of a container. That's what you can see here. Why applications are deployed as containers. And if you want to deploy your application in the form of a container, what are the steps that you need to follow in order to build and deploy a container? And of course, you see in an organization, more and more containers are getting deployed each and every day. So I'm going to understand, or I'm going to talk about an important component called Kubernetes. What is the role played by Kubernetes? And of course, there is one managed service called Google Kubernetes Engine, which is very much called as GKE. And what are the features of this GKE? So technically, this webinar gives you the basic understanding on containers and now why industry prefers to deploy the applications in the form of a container, and what are the steps that you need to follow in order to build and deploy your application in the form of a container. And other than that, you are going to talk, you are going to get an understanding on what is the importance of an component called Kubernetes. And of course, we are going to end up with the GKE. So what do you mean by GKE and what are the features of GKE? So hope I can move forward to start off with what are containers. Let us try to understand the term containers. As you can see in a real time, you might have seen most of the containers they reach the harbor. From the harbor, they port the containers from one place to the other place. So interestingly, whenever we try to understand the term containers, it means it is a box which contains everything. That is the literal meaning that you can understand for containers. So containers means whenever I want to move, some of the components or some of the elements or big machineries along with n number of components, what I will do, I will prepare a box. In that box, I will put everything, and then I move the entire box from one place to the other place. This is the actual understanding on the term called containers. So whenever we say containers, what is the real advantage of it? It means that portability. What do you mean by portability? You can move the containers from one place to the other place. So what is the challenge and what are the features, yeah, that we are going to talk about? Hope you get to know, or you will be understanding how it is very much used, or how the term containers is very much used in the IT industry. That's the way how you can understand. So I believe you understood now what is container. It is nothing but a box which contains everything, which helps you to move, yeah, the component from one place to the other place as a whole. That's what the way how you can understand the term called containers. And how do they work? Hope I can explain down the slides where you can understand how the containers works. Yeah, once, or if you want to deploy your application in the form of a container. Hope I can move forward. Yeah. So in order to understand how it is very much, or before we try to deploy our application in the form of a container, let us try to understand the term container in a more elaborated way. Long back, yeah, the normal way of deploying an application, yeah, is on a local computer. Everyone knows a computer will have an operating system, it has the software dependencies, and of course the computer has the power, I mean the processor, it has the cooling, it has the network connectivity, it has its own physical space. So what I'm trying to say here is, earlier days the applications were deployed on a local computer. So what is the challenge they had when they deploy in a local computer? Portability. If they want to move the application from the local computer towards a different environment, so they have a challenge. What is the challenge? In the new environment, they need to check the hardware, they need to check what type of operating system that is present in the hardware. So that's the way how they face the challenges whenever they want to migrate from one place to the other place. Surprisingly, you may ask a question, why can't it run in the local computer? As I said, it keeps running in the local computer, think that there is a sudden hardware failure. So if sudden hardware failure happens, obviously you know very well, yeah, the application won't run, the users cannot access. So earlier they used to deploy the applications on a local computer where they had challenges in terms of portability, in terms of the hardware, in terms of the software. So in order to overcome the challenge, yeah, they came up with the concept of virtualization. I hope everyone might have heard about this term called virtualization. So what is virtualization? It is the process of creating a virtual version. Let us take, for example, in your laptop or in your desktop, you have a hard disk. The hard disk is a physical device. This device you logically divide into C, D, E, and F based on your need. So one physical device which is logically divided into n number of virtual. That's what we mean with virtualization. So any physical resource, it may be a server, or it may be a storage device, or it may be a network, which you divide virtually on a physical device. That's the concept of virtualization. So now you need to understand the flow. Earlier it was one single machine. That's what we call it as a local computer. So next, they came up with the concept of virtualization. So what is virtualization? Dividing the physical device into virtual. It may be a server, it may be a physical resource, or it may be a storage device, or even it may be a network. So with the concept of virtualization, you see, we get much more advantage when you compare with the earlier model of local machine. What is the advantage? It takes less time to deploy new solutions. Whenever I want to deploy a new application in the virtualized environment, it takes only few minutes. And in terms of the resource utilization, only less resources are wasted. It means that in earlier model, it was on a local computer where more and more resources are wasted. After the concept of virtualization, yeah, the resource wastage or the resource utilization has increased, where the resource wastage is much more reduced. The other important advantage here is portability. What is portability? Just now I said, whenever I want to move my application from one environment towards a new environment, yeah, with the concept of virtualization, yeah, it is increased. Though we say increased, still we have challenges. So earlier it was on a local computer, and then the concept of virtualization came, where the portability is little bit improved. What are the challenges? Even now, yeah, if I want to move the entire virtual machine from one environment or from one place to the other place along with hypervisor, it is very difficult. And the entire virtual machine will take its own time to get booting up. So let us take for example, your laptop is getting more time to get booted up, where yeah, once it gets booted up, then only the application will run, then only the users can access. So initially it was on a local computer where they had much more challenges, and after that, with the concept of virtualization, they felt a little bit improvement in terms of portability, in terms of resource utilization, in terms of deploying new solutions has increased. And adding to the virtualization, yeah, there is one more term that we need to understand, or which gives you much more advantages, nothing but hypervisor. If you see this slide on the left hand side, it was the old model where you can say I have a hardware. Kernel is nothing but the operating system. My application code runs along with the dependencies. So this is nothing but a dedicated server, or in simple, this is the local machine. And when you look at this left hand side slide, it talks about the dedicated server, where it was a old model where the applications were deployed. Now we know very well virtual machine. What is virtual machine? I divide the hardware. Just now I said, yeah, I divide the hardware. And who does the division of hardware? Yeah, interesting. Yeah, software, which is very much called as an hypervisor. So hypervisor is nothing but a software. It is also one type of operating system, yeah, which helps you to divide the resources. What are the resources? Processor, RAM, storage, network. So everything is divided virtually, and that's what we say that as a virtual machine. So if you see this as a virtual machine, the virtual machine where it runs the application along with the dependencies, and you can see kernel. Kernel is nothing but the operating system. So now, if you ask me what are the examples of hypervisor, you can see yeah, KVM. What is KVM? One type of hypervisor. Hope you might have heard about yeah, Citrix. It is one type of software or an operating system which helps you to share the resources. So from the local machine, I mean the dedicated server, they moved to the virtual environment, what we call it as a virtual machine. Still the virtual machine where the hardware is very much managed by the hypervisor. Hope you got the flow. Hope I can move forward. Now from the local machine, they moved into the virtual machine, and now they started thinking about how they can increase the performance, or how the resources can be effectively utilized. So now if you see the diagram is same, where you can say I have the hardware along with the hypervisor, kernel is the operating system. Now they started thinking about, yeah, why can't we deploy more than one application in the same virtual machine? That's what the diagram talks about it. As you can see, I have a virtual machine. In this virtual machine, you can see I have deployed two applications. Now, once they deployed two applications so that they can reduce the resource wastage, and they thought of increasing the performance, but they ended up with a new challenge. What is the new challenge? Let us say, for example, this application one, which runs in the virtual machine, is using the dependencies, yeah, and at the same time, the second application is waiting for the resources. What I mean here is the dependencies are not isolated. So that's what you can see the caption: application that share the dependencies are not isolated. Why? Because at any single point of time, one application can access the dependencies, whereas the other application has to be in wait state. So this is a new challenge they got, even though they came up in the virtual machine and in a virtual environment. So in order to overcome this challenge, yeah, the next level of idea what we got is, why don't we run every virtual machine as a separate entity? That's what you can see. I have a separate virtual machine. In this virtual machine, my application code along with the dependencies, along with the kernel, which will run as a separate, so a dedicated machine. So now, initially it was on a local machine, then they started deploying multiple applications on the same virtual machine, and next they came up with an idea, why can't we run separate virtual machine along with the dependencies? So that's what the diagram here shows, as if in order to increase the performance, in order to minimize the resource wastage, they started thinking as if they run every individual machine as a separate. That's what you can see, run a dedicated virtual machine for each application. So here also we had a challenge. What is the challenge? Let us take for example, yeah, if I want to upgrade the kernel, or if I am trying to, let us take for example, in my environment there are 1,000 virtual machines that are running, every virtual machine where I have deployed an application. If I want to upgrade the kernel, let us take for example, the kernel runs with the version 6. Now I want to upgrade with the latest version called 6.5. If I want to upgrade the kernel, it means that I want to do the same process for 1,000 times. Why? Because I have 1,000 individual virtual machines where I mean running in my environment. So even though we came up with the concept of running a dedicated virtual machine for each application, yeah, we came up with the concept, we ended up with the challenge, as if I want to upgrade the kernel, I need to do the same thing for thousands. So in order to overcome all these challenges, the concept of container came, what we call it as, why don't we make the application, yeah, I mean the isolation at the application level. Yeah, in every virtual machine I deploy the application along with the dependencies as one single entity. That's the interesting point, what we call it as container. So earlier, if you see on the left hand side, I have a dedicated server where you can say I have the hardware, kernel, dependencies, application code. So now in nowadays in the cloud environment, what we do, we have the virtual machine. Now I can deploy my application along with the dependencies which run as a separate user space. That's what you can see. I have a separate user space for my application. I have a separate user space for other application. So now the real advantage of doing like this is nothing but what we call it as a container. That's what we implemented, the abstraction at the level of application and its dependencies. Earlier the dependencies were at the resource level. Earlier it was at the hardware level. So now what I do, I prepare a container. It means that I am going to run my application along with the dependencies in a separate user space. That's what the concept of container. Hope you got the real idea behind why nowadays, yeah, the industry follows the deployment of application along with its dependencies as a separate entity, what we call it as container. Technically it is very much called as an hypervisor also. Moving forward, yeah, so now interestingly you got to know what is containers. As per the definition, containers are nothing but isolated user space. What does it mean? It is an separate entity. It means that it doesn't shares the resources with other container. Every container runs as a separated, isolated user space, in that where the application along with the dependencies will run. And interestingly, you can see containers nowadays become lightweight. What is lightweight here? I can move the application along with the code, along with the dependencies, which is nothing but the form of a container, from one place to the other place. Why? Because containers don't carry a full operating system. In the earlier slide, if you see, I was showing a term called the kernel. Kernel is nothing but the very important operating system file. to make it simple, let us take for example, your operating system is a collection of 100 files, but the kernel is nothing but only 5 to 10 important files which are very much required, that we call it as a kernel. So now every container will have a kernel, every container will have the application code, every container will have the dependencies, the container will have everything, and everything I put in a box, that's what we call it as a container. So containers are lightweight because it doesn't have the full operating system. Containers can be created and shut down very quickly, not like the earlier virtual machine where I have an application, the shutting down and the start of the application takes its own time. So why? Because as you can see the last point here, containers do not boot the entire virtual machine. It will initialize the operating system. So that is the beauty of what we call it as container. So containers are isolated user spaces, which helps you to run your application along with the dependencies. That's what we call it as container. Now, what is the real advantage of this one? Portability. So now if you want to deploy your application in the form of a container, so and you can port it from one place to the other place. Let us take for example from your local desktop or laptop, you can you can develop an application and you can deploy that in the form of a container. No need to worry on the hardware dependency, the software dependency, or any other dependency, because everything is present in one single box, what we call it as containers. So containers are isolated user space which helps or where the application code will run along with its dependencies. Okay. So now, is there any special hardware or software or device or a server that I need in order to develop a container? No. You can develop the containers in a much more usual way, as like the way how you develop an application by writing a code. Simply, you can develop your own application and that will be executed in the virtual machine in the form of a container. That's what you can see. Develop containers in the usual way. So there is no special environment, no special hardware, no special software is very much required in order to develop the container. You can develop the container in a usual way and that will be executed, or the container will run in a virtual machine. As you can see, you can develop the application code either by using a desktop or laptop or whatever server that you have, and that will be deployed the form of a container which will run on a virtual machine. So that's the way how you can see what we mean with the importance of container. So no special environment, no special hardware, no special software, or no any other prerequisite is very much needed in order to develop the container. It is very much developed in usual way, and that's the way how you develop the container. Once you developed it, it will be executed or it will run in the form of a container in the virtual machine. Okay, so interesting question comes now. Why applications are deployed as containers? If this question comes to you, the very good answer that you can say, code will run successfully if it is on a local machine or in a real production environment where the users can access. The interesting one term that I can say, portability. You can move the application from any environment to any other environment because it is in the form of a container. What is container? It contains everything in one single box. That's what you can see, which gives you high performing scalable applications. What is scalable application? I can run multiple copies of the same application when more and more users are trying to access at the same time. So they provide access to reliable underlying hardware and software, and the application code will run successfully irrespective of whether it is on a local machine or in a real server or in a production environment. And when you want to create your application in the form of a container, it is much more easier because all the containers follow an architecture called microservice architecture. recently or in the entire industry, we follow architecture called microservice. Earlier, the architecture was monolithic. What is monolithic? To make it much simple, I am developing an application. The application code is of 1,000 lines. In earlier days, what will happen if there is any bug in my application? I need to shut down the application and I need to sit and debug, and then only I can deploy where the users can access. What does it mean now? It takes its own time for you to debug. But nowadays, we don't follow the monolithic. Nowadays, we follow the microservice architecture. What does it mean? The same 1,000 lines is divided into smaller units. For example, 100 lines, I make it as one container. The next 100 lines, I make it as one container. So that's what we mean with microservice architecture. And if one of the container is not working, for example, it doesn't mean that the entire application is down. Still, the other containers will run as if in the meantime I can sit and debug the issues related to the container which is not running. What I'm trying to say here is, earlier it was a monolithic architecture. Nowadays, specifically on the containers, we follow the microservice design pattern. So that's the way how the developers, they can build the applications very easily because they use the microservice architecture. So that's what the interesting answer for the question, why industry now, or why the developers, or why applications are deployed as containers. Two important reasons: code will run irrespective of the environment. That's what we mean with the portability. And developers, they can make or they can build the applications very easily, the time taken, because they follow the microservice architecture design pattern. Hope I can move forward. Yeah, I believe now we got the clarity on what is container. Yeah, hope you understood what is container. So every container will come from a container image. As you can see on the left hand side, whenever I say the container, it contains the application, the dependencies, and I make it as a container image. So every container comes from a container image. For example, if I want to deploy my application in the form of a container, I should create a container image. So from the container image, I can deploy that as a container. So usually what we say, we say there are three important steps that you need to follow whenever you want to deploy your application in the form of a container. We say build, store, and run. What is build? Build is nothing but where you prepare the container image. Once the container image is prepared, then you store that. Once you stored that as an image successfully, then by giving a command called run, that image will deployed in the form of a container. That's what you can see. Developers can pack and ship an application without worrying about the system that it will run on. So if I am a developer and if I want to develop my application in the form of a container, no need to worry on the hardware, no need to worry on the software, no need to worry on anything. Simply you put everything in one single box, what we call it as a container, and you can deploy it, and which helps you to port from any environment to any other environment. So basically every container has to be built from a container image. Now let us take for example, I want to deploy multiple containers. So how do I do that? Obviously you need a software. Just now I said no, you need to prepare a container image. So how do I do that? I need a software in order to build the container image. The name of the software is nothing but a Docker. As you can see, the diagram clearly makes you to understand with the help of a open source, called Docker, and Google Cloud Platform is very much supportive for open source and open source technologies. Don't ever think that Docker cannot be used in Google Cloud. It can be used. Why? Because Google Cloud Platform is so flexible in such a way that you can use any of the open source technology. So now, whenever I want to build my container image, I go by using a open source technology called Docker. So with the help of the Docker, I prepare a container image. So that's what you can see. Docker is a open source technology. it can be used to create and run applications in container. So with the help of the Docker, what I can do, I can create a container image. Through that, I can deploy that in the form of a container. So Docker doesn't helps you to orchestrate. What is orchestrate? It won't help you to guide step by step. Yeah, as if whenever you want to scale that. What is scaling? I want to run multiple copies of the same application where more and more users are trying to access. So we have some limitations with the Docker. Hope, yeah, when you try to explore more on the Docker, you will come to know. But as of now, I believe you understood Docker is an open source technology which helps you to create the required container image, and that can be, I mean, the container image, and that can be deployed in the form of a container. Okay, so now every container, yeah, comes from a container image. So you can see a sample diagram of a container image. As you can see, every container image has two layers. One we call it as a base image layer. The other we call it as a thin read write layer, which is very much called as a container layer. So every container image will have two layers. One we call it as a container layer, which is read write writable layer, and it has one more base image layer, which is read only. What is read only? Which you cannot do any changes. What I mean here is, whenever I want to create a container image, I prepare a Docker file. The Docker file will have all the information in such a way that I can create a container image. To make it much simple, I will tell you an interesting example. Yeah, why do I need this container layer, and then why do I need this base image layer? I want to deploy, yeah, multiple instances of the same application, multiple copies of the same application I want to deploy. What I can do, I can prepare a container with base image, I mean layer, and as well as the container layer. If I want to redeploy it again, what I can do, so I can simply change the container layer. It is so easy. Think that you are preparing ice cream and you are selling it. The ingredients are same, but whereas in order to get the different color, you change the flavor. So you change one of the, yeah, step in such a way that you get the different flavors of the same ice cream. So the ingredients along with the ice cream, what we call it as a base image layer, and whenever you want to change the color of the ice cream, you just do some changes, what we call it as a container layer. So every container image has a base image layer which is read only, and the container layer which is read writable layer, which you can do the changes. And basically I prepare the container image from a Docker file. That's what you can see. It talks about from talks about the operating system, the kernel, and copy talks about the source of the application code and what are the commands that I can execute, and CMD stands for the command. So basically here you can see a snapshot where I'm creating a application called app.py, which is made up of Python, and I copy the entire application along with the dependencies along with the kernel. That's to be how I prepare a Docker file. Why? Because once I prepare a Docker file, through that I can create a container image. Okay, so whenever you prepare a Docker file, why? Because yeah, creating a Docker file is very important, which helps you to create the container image. So every Docker file will have these four basic commands. As you can see, from talks about, yeah, the kernel, the operating system. Copy dot, yeah, app talks about the source code. And run, yeah, what are the commands, yeah, that you can use it whenever the application is deployed. And specifies what command will be running. So what are the commands that I can use within the container? Everything I put in my Docker file. Through the Docker file I create the container image. So whenever you want to build your own container image, it is so important, yeah, you need to understand how effectively I can prepare a Docker file. And the Docker file basically will have the four commands, like from talks about the kernel, copy talks about the source code, and run, yeah, which helps you to execute the results. And the last CMD talks about what are the commands that I can execute within the container. So every container that you prepare, or every container image that you prepare, basically all these four entries will be present in your Docker file. Why? Because Docker is a open source. Hope I can move forward. Yeah. Now, let us say, for example, I don't want to create my own containers. Is there any container image already available through which I can, yeah, use it? Yes. So there are different ways in which you can, deploy the application in the form of a container. As you can see, either you can create your own container image, or from an existing container image you can, use that container image to deploy that in the form of a container. So that's what you can see. Either you can go by using publicly available open source container images. To make it much simple, I will tell you an interesting example. I'm asking you to create a professional business letter. So what we do, we go to the Microsoft Word. There I have a predefined template called professional business letter. I select the template. So once I select the template, it gives you the entire body of the letter where I can incorporate my own words, and that's the way how I create a professional business letter. Like that, already I have some open source container images through which I can keep that as a base image. From that I can create my own image. This is one way of creating the containers. Specifically in Google Cloud, we have artifact registry. Artifact registry contains public and open source images through which you can create your own container image, or you can use the container images in any other public repository like Docker Hub or GitLab. So either you can go by using publicly available, or from Google, from the artifact registry, where it has all the open source images, which is public and private collected container images through which you can create your own container. Or if not, you can go by using public repositories like Docker Hub registry and GitLab. So these are the places or through which I can use those existing container images through which I can create my own container. So it is not like always you need to go by creating your own. You can use, you can go by using the existing container images, as like what I said, publicly available, which is open source, or Google Cloud artifact registry, or other than that, you can go by accessing the public repositories like a Docker Hub registry and GitLab, through which you can create your own containers by using those container images. No, I think in a different way now. I want to create my own container image, and through that I want to deploy the application in the form of a container. If so, Google Cloud gives you a super and special service, what we call it as cloud build. It is a managed service, so which helps you to build the container. I believe I said whenever you want to deploy your application in the form of a container, you need to build, you need to store, and you need to run. So either you can go by using the existing, what I said in the previous slide, or right from the scratch, I want to create my own container image through which I want to deploy that in the form of container. Is there any special service that is very much available in the Google Cloud? Yes, the answer is cloud build. So it is designed through cloud build. You can retrieve the source code irrespective of whether you access that from your local machine or from any of the other repositories like cloud source repositories or GitHub or Bitbucket. Let us take, for example, instead of storing the code in my local machine, I have stored in GitHub. Can I access it through cloud build? Yes, you can do so. So cloud build is a managed service which helps you to build your own container right from the scratch. So either you can go by using the existing container image, or if you want to build your own container image right from the scratch, you can go by using a service called cloud build, through which you can create your own container image through which it will be deployed in the form of an container in the Google Cloud platform. Now we go by knowing the interesting term called Kubernetes. So far we discussed elaborately, the idea behind containers. Now let us take, for example, in organizations, there are multiple containers that are getting deployed. Let us take, for example, a company deploys 200 containers in a day. So now I need a tool, or I need a software where I can manage the running containers, right? That's what we mean with Kubernetes. Kubernetes is nothing but it is so simple. It is an open source platform for managing containerized workloads and services. So once the application is deployed in the form of a container, for example, I want to scale it, or I want to change the resources. So I want to manage the containerized workload, right? Through which I can do so Kubernetes. It is an open source platform. It is an open source platform which you can manage the containerized workloads and services. What it will do, it will guide you step by step how you can, yeah, design, develop, and deploy your application in the form of a container, and how you can scale them. And if in case if you want to do changes later, for example, my application runs with version 1, I want to upgrade to version 2, so I can deploy the rollouts. No, I don't want to do those version upgrade. I want to roll back. So whenever you want to, yeah, whenever you want to, yeah, do or manage all these things, that's the way how we can go by using this Kubernetes. So hope, yeah, I can stop over here. Yeah.
Thank you so much, Mr. Sai Subramaniam.
Yeah,
Can we take the
thanks.
questions, Mr. Sai?
Yeah, sure.
Thanks for. So, can you please stop sharing your screen? Thanks for giving me a chance to address your questions. And now let's start with the first question. Gurpreet is asking here, how does Google Cloud build assist in building and deploying container images on GCP services?
Yeah, that's what I said just now, right? Cloud build. Cloud build is an important service which helps you to create your own container right from the scratch. See, the important steps in order to deploy your application in the form of container is you need to have a container image. So whenever I want to start from the scratch, hope so we discussed right now. Cloud build is an important service through which you can create your own container image through which it will be deployed in the form of a container. Specifically, it is for Google Cloud Platform.
Thank you so much, Mr. Sai Subramaniam. Ms. Kunsirat, you want to add something in this?
Sure. So, as Sai sir has already covered most of the major points, I would like to put forward that containers are very useful when you're deploying applications, and learning containers, whether it is through GCP or any other cloud provider, it is very important for us, right? So it's a more prevalent technology above the surface of cloud. So if anyone is reluctant in cloud, they should go for containers. They are easier to manage and easier to handle. That's all I want to add. Thank you.
Thank you so much, Ms. Kunsirat and Mr. Sai Subramaniam. I hope Gurpreet, you got your answer from our today's experts. Can we take the next question? Yeah,
Yeah, sure.
Radhika is asking, what are some advantages of using containers on GCP compared to traditional virtual machines?
Yeah, that's what I said. In traditional virtual machine, you cannot port it, yeah, easily. What I mean with porting, for example, if I want to move the application from one environment to the other environment, if it is in the form of a container, yeah, it is very easy. The second important point here is in a normal virtual machine, whenever you want to move or whenever you want to migrate, you need to take the entire copy of the operating system. That makes you heavyweight. And moreover, you need to check for the hardware and software dependency in the new environment where you are going to install that. Instead, yeah, if it is the form of a container, I am not going to take the entire copy of the operating system, only the kernel, which makes me lightweight. What I mean with lightweight, portability. So that's the way how, compared to the normal way of deploying the application in a normal virtual machine, if you deploy that in the form of a container, portability is much more easier, and moreover, no need to check for any hardware or software dependency.
Thank you so much, Mr. Sai. Someone is asking here, what are the steps involved in deploying a Docker container on Google Cloud Run using the Cloud Console or CLI?
Yeah. So in both way you can do so. Either you can go by using a CLI or either you can go by using the cloud console. First, you need to create a cluster. So the cluster can be in the form of a, yeah, Google Kubernetes cluster. So basically you need to create a cluster, and when you define a cluster, you need to tell how many nodes that you want inside the cluster. Then, yeah, once you created the cluster along with the nodes, then you can deploy the application which runs in the form of a pod inside a container. These are the steps that you need to follow whenever you want to deploy your application in the form of a container. You need to create a cluster along with the nodes, and then you can roll out or you can deploy your application, which is nothing but which is very much called as a pod.
Yes, thank you so much, Mr. Sai. And Ms.
Yeah.
Gunsira, do you want to add something in this?
I think Sir has already covered much of the points, major points which are needed for containers to be deployed in GCP or any other virtual machine or cloud platform. So I think that's all.
Thank you so much, Ms. Gunsirat Kaur and Mr. Sai Subramaniam. If anyone have any questions regarding the admissions, they just write on us at admissions@lpu.co.in. You can do WhatsApp chat with us. Our WhatsApp number is 985256900. I'm repeating the number, it's 985256900. As we come to the end of this webinar, I want to express my deepest gratitude to our experts for sharing their valuable insights and expertise with us. Your presence, enthusiasm, and active participation have made this experience truly special. Hopefully, the attendees found this webinar to be valuable and will be able to utilize the information for better decision making regarding admissions. If anyone wants to access this webinar again, they can visit our website, that is lpu.in, or can be accessed on YouTube also. Stay connected with us for future webinars. Until we meet again, with the permission of my seniors, I would be signing off this webinar. Take care and goodbye. Have a beautiful day.